This is an idea, might work, might not. PowerPoint presentation, having trouble putting it onto the old Macs, so I thought I'd make a little Windows media file thing, and I'd like you to make notes, pause the video of course as you go along, and I'd also like you to write 5 questions that I could include at the bottom of the VLE page. Okay, I'm not going to read it to you because it's too early to read. But I would put on sound effects. Conduction, convection, radiation. There they go, moving. See, on my PowerPoint, these are moving. Hopefully it will come through on the video. All that kinetic energy. Classic. Here we go. Right. Heat is conducted along the copper. Bingo. How conduction works. Jiggling. You might want to pause and make some notes. Why not? Yeah, this is a little bit more advanced. Conduction is about jiggling ions, but also delocalized electrons. That's why something like quartz, I think, is a good conductor of heat, but a poor conductor of electricity, because it doesn't have free electrons, but it can vibrate. So 2 methods. Why is the chef using a cloth to hold the pot? 4 odds. I'm going to put these in order. Here we go. I reckon it's going to be copper first. So I'll put that in. Right, let me do it. Doop, doop. Doop. Well, to be honest, I lost count. I'm going to have a go. Copper. Brass or steel, I reckon. No, brass then. Oh, wow, interesting. Ooh. Ooh. Thank you very much. Conductors and insulators. Metals are good conductors because of the electrons. Oh, don't talk to me about insulation. Right, convection. You can read all that. And I'll press start. No. It's important to get keywords here like density rather than just say heat rises. You got it, but you got these big keywords. Eh? All right. And sea breezes. We did this in class a bit. So during the day you get onshore breezes due to convection currents, and during the night, is it going to show? Of course, evening and night, even though there's a picture of the day, but never mind. So this is night time. Okie dokie. Okay, we got this. We can show you this. The smoking paper. Questions about mines and things. Inside the smoke chamber, hot air above the candle. There you go. Put that in there. Rises, and cold air is drawn down. Very good. Oh yes. Not well named. Excuse me. So the warmest place in my house is put in the ceilings. Okay, thermal radiation is different completely because it doesn't involve particles. Complicated the more you think about it. You'll be introduced to this electromagnetic spectrum, but basically it's just types of light. Some lights you can see, all these different types of light you can't see. Note that radio waves is light, not sound, and to do with wavelength. Yeah, we do this again and again, but infrared's there. You notice that, eh? Infrared radiation. Yes, Kellen. Good boy. Because it's a light, type of light. Okay. Alright, now. Alright, so the idea is you've got to get your head around that infrared gets absorbed by your atoms and also gets emitted. So in the case of the hot object here, we got a hot object. What are you doing? Emits more than it absorbs. Get in there, my son. Right, a cold object absorbs more than it emits. If it remains constant, rate of absorption and emission is the same. Yeah, it's always difficult when you talk about people because people are warm-blooded animals, so not so good for talking about the laws of thermodynamics. Absorption experiment. Okay, now colour is related to light. Colour is really interesting. What have we got here? So we've got Bunsen burner is going to turn on. Which one is going to be the best absorber and emitter? Work this out. You see, the black is absorbing the heat, the white is reflecting it. It then emits the heat. It shows that dark surfaces absorb more infrared than shiny surfaces, or light probably. Yeah, it's going to be light surfaces up there. No, shiny, yeah. No, light. Come on, back you go. There you go. And experiment 2, where you've got a shiny black and a matte black. So it's absorbing heat, re-emitting heat. There you go. So it shows it's shiny, absorb more, and then, oh no, I've got it all around, eh? See, that's the matte black there, and that's the shiny black there. Okay, so this one's about emission. So, which one gives off the most amount of heat? Obviously the matte black, followed by the shiny black, shiny white, matte white. No, sadly. Matte black's first anyway. Shiny black's next. Matte white is third. So this is how they emit infrared. What's for breakfast? A substance which is a good reflector of heat is a poor absorber of heat. That's why white snow stays frozen. A poor reflector is a good, so black coal sinking. Okay, size of object, I reckon this is all pretty. You see, if something's hot, it contains more energy. No, something's big, like a hot bath, contains more energy than a sparkler. This experiment demonstrates that a smaller object, larger object cools more slowly than a smaller object. And shape of object, well, I reckon the tray is going to lose it quicker. Right, the same amount of water as greater. And order in the narrower beaker. This demonstrates that with a large surface area, faster than with a small surface area. Oh. Might be worth writing down. How many more of these have got here? What's this? Oh, we've got a fridge. There's a fridge. Look at that. That's excellent. So what we've got is a bigger temperature difference. We've got hot water in a fridge. And this is hot water in a room, I reckon. So let it run for a few minutes. And look at that. The one in the fridge is getting cooler quicker. There's a surprise. The experiment shows that the greater the temperature difference between the object and its surroundings, the greater the rate of heat transfer. Good luck, I hope this works.